Hello class, I wanted to give a little more context into the assignment for the lift and gain charts and uh, provide some further guidance for your homework this week. So what's happening here is we have a marketing response model, and the context for a situation like this would be if we knew, for example, that if we send a marketing campaign to every single customer we have, which in this case is 100,000 customers, that the best response we're going to get is 25%. So 25,000 responses. But we want to know if there's a better way to get a high number of responses, but contact far fewer customers, because every marketing campaign we do, whether it's sending batch emails or flyers in the mail, costs money, right? So if we don't have to contact all of our customers, then we want to find a model that will uh, group for us the most likely to respond, and we'll focus on those customers instead. So prior to collecting this data, we would have known a lot of things about our customers that we've collected from their website traffic, their forms that they fill out when they purchase something. Google provides analytical data for businesses, so we might have demographic data. We know like their zip code. Um, we might know their income bracket, their gender, all kinds of variables, their frequency of purchasing from our company, when they last recently purchased, um, how much on average they spend per purchase. All of those things can be used in marketing to build a model to take in customer information and determine whether or not they're going to respond to a marketing campaign. So let's say we've done that, and now we have the results of our model, and we want to know how much better is our model than mailing to a sample of our customers, and um, where do we start to see diminishing returns on our response model. So if we were to contact 10% of our customers, then we would expect to see 2,500 responses if we just randomly sampled 10,000 of our 100,000 customers. However, our model gave us 7,000 responses. And you see these plotted here in the ratios of the percent of positive responses and the percent of customers contacted. So if we expect 2,500 responses from 10% but got 7,000, we can calculate the lift curve, or the percent of positive responses from the model out of the total expected positive. So when we send it to 10% of our customers, we would get from our model 7,000 out of 25,000 versus the 2,500 out of 25,000. So that's what you're seeing here is that ratio. So this is the 2,500 out of 25,000 and the 7,000 out of 25,000. So that calculation goes incrementally from 10% to 20, 30, 40, 50, 60, 70, 80, 90, 100. And this is based on this data here. Then for the next calculation, when we're trying to do the lift chart, we're looking at our baseline again, so with no model, 0 all the way to 100%. And then we're just calculating the overall lift for the whole model. So this is kind of the ratio of the number of the lift curve divided by that baseline. And so basically our lift is pretty high early in our model, 2.8, and then it diminishes as we get closer to mailing out to all 100% of our customers. So it's kind of just two different ways to look at these responses from the model to help a marketing team decide what approach they should take. So in this case, we might say that for 50% of our customers contacted, so basically cut our mailing uh, in half, and therefore the cost of our marketing campaign in half, we're still going to reach 84% of the customers that we would have reached if we had mailed to everybody. And so that's a pretty good return. If we wanted to save even more money, we could even cut down to 40% and still get about 75% of the responses, positive responses that we would have gotten if we had mailed to all 100% of our customers. So you can see how this would feed into a larger optimization problem where, given a budget constraint and some other factors, you could help lead your organization make the decision about how to optimize your marketing funds to get the highest rate of responses. And you can also see how well your model is performing. So we can see that there's a time in the model where it's kind of performing its peak above the baseline expected results if we didn't have the model at all. And then for the lift chart, it's just a kind of a different way of looking at it. And here you can really see the diminishing returns as you mail out to more and more and more and more and more and more of your customers and get closer to just mailing out to your entire customer base. So I hope that's helpful for adding context and for completing your assignment.